So I just wanted to go over a much easier way to solve the example we went over in class 2 days ago, or day ago, that Keegan showed me. So here we have the problem where the security system in a house has two units that set off an alarm when motion is detected. Neither one is entirely reliable, but one or both always goes off. So if you think about one or both always goes off, that's A or B. And since that always happens, that's 100% of the time. When there is motion anywhere in the house, so when there's motion anywhere in the house, A or B or both go off. So 100% of the time, one of them goes off, at least. Suppose that for motion in a certain location, the probability that detector A goes off and detector B does not go off is 0.25. So that would be, and of course is the intersection, so A intersect B complement because B does not go off. And the probability that detector A does not go off is 0.35. So A does not go off is the probability of A complement is 35%. Now we know, and this is very important, from what I highlighted in blue, we know that the union of both events is 100%, so that's really the whole universe of things that can happen. So that tells us that at least one detector goes off. That's the probability of A union B, 100%. We also know that detector A goes off and detector B does not go off with a probability of 25%. So the probability of A intersect B complement is 25%. The third piece of information we were given is that the probability of A does not go off is 35%, or the probability of A complement is 0.35. So we're going to use that information, and what Keegan's trick was, or what she thought of doing, was using a Venn diagram. So we use a Venn diagram as Keegan suggested. One thing we know is that when we put A and B together, it's 100%. Now we were told what A union or intersect B complement is, and that's 25%. So that's the part of A that doesn't include B, so that's not in the overlap. We're also told that A complement is 35%, but since everything is contained in A and B, that leaves the 35% to be in the part of B that doesn't overlap A. Since we know both A and B or A or B put together, their union is 100%, that must mean the overlap is whatever's left. So 0.25, 0.35 adds up to 60%, so 40% is left in the intersection. So we think about that. If we're asked the question, what's the probability that B goes off, we can simply add the 0.4 and the 0.35. So the probability of B equals 0.4 plus 0.35, and that equals 75%. So using a Venn diagram is actually quite a bit easier, and I thank you, Keegan, for that.